Hello, ladies and gentlemen, boys and girls. Today we are going to add and subtract rational expressions. This is day one of the last section that we will cover this school year. So pay attention. It's going to be a few details that we have to pay real close attention to, and then tomorrow we're going to make this a little bit more challenging. But to start, let's make sure we review some of our prior knowledge. Specifically, adding and subtracting fractions. I want you all to press pause and try these four problems up here at the top. Now, please check. The three that are highlighted are completely correct. The one that's not is not completely correct. And what's the main reason why? That's right. It's not simplified. You always have to simplify fractions. So 3 goes into 6 twice, and 3 goes into 9 3 times. Now I have a completely simplified answer. The key to what we just did here when we are adding or subtracting fractions is that we always must have a common denominator. And that when we are adding and have that common denominator, we always add or subtract our numerator, but you keep the denominator that's common. And lastly, make sure that you always simplify like we did in this problem up here. The next thing that we have to review is the distributive property and combining like terms. So for our purposes, I'm going to abbreviate these two as we are starting to write these. I'll abbreviate distributive property, DIST, or distribute, and then combining like terms, I'm just going to write as capital C.L.T. So combine like terms. And the whole process here, again, you guys have done. This is chapter 1. Go ahead, press pause, and complete these 4 problems. Now make sure you check your answers, and again, kind of summarizing here, if it's an addition problem and I am adding to binomials or trinomials or any kind of a polynomial, it's just combine like terms. Any addition problem in between the parentheses, so focus on what's in between the parentheses, that's combining like terms. If it's a subtraction problem like it is in these 2 examples, one's binomial minus binomial, one is monomial minus binomial, you must first distribute that negative, then combine like terms. So my positive 3x becomes minus 3x, plus 2 becomes minus 2, positive x becomes minus x, and positive 10 becomes negative 10. If that were x minus 10, this would have been x plus 10 at the bottom. And then it becomes a combine like terms problem. Remember, when we're combining like terms, you combine your coefficients as long as they have the exact same variable and the exact same exponent. So for the most part, today's lesson is just that, except we're going to have denominators that have the variables. And a couple examples, making sure 100% of the time that before we add or subtract, these rules up here still apply. We need to have a common denominator. So before I add or subtract anything in my numerator, I must have a common denominator. If I look at this example, I have x minus 2 and I have x minus 2. It doesn't matter that those are binomials. They are one common denominator. That's all I need. I keep the denominator, that common x minus 2, and I combine my numerators, 3 and 7, and this was an addition problem, so I add them. 3 plus 7 gets me 10. X minus 2 is my denominator. I'm done. I've just added my first rational expression. In the second example, the concept is identical, except common denominator, 3 minus 7. So what's the difference? I'm going to take 3 and I'm going to subtract 7. With my common denominator of x minus 2. And you keep the denominator just like we did above. 3 minus 7, well, that's negative 4. X minus 2 is my denominator, and we're done. When does that become different? Well, right now it's not going to come too different at all. Same exact denominator, keep it. I'm going to be adding these expressions. 2x plus 1 is the denominator. Now you have a binomial and a binomial. Here we just had integers. The only thing you want to consider now is these binomials are kind of grouped together on their own. So not together with each other, just grouped. So I want to consider the fact that I'm adding this numerator plus this numerator. In this case, it's an addition problem. Addition problems are just like above. It's not as big of a deal. Because when I have an addition problem, just like above, it's combined like terms. So in this case, I have an 8x and a 1x. I am adding these, so I take my x plus my 8x, and I get 9x in the numerator. And then I also have a -3 and a -1, so -3 minus 1. I get 9x minus 4 as my numerator. I keep the denominator the same, 2x plus 1, and we're done. Same concept, different outcome in the next example. Same concept because they have a common denominator. First and foremost, I have to always look at that. Keep the denominator, but now it's a subtraction problem. So I'm going to subtract numerator minus numerator. And those parentheses are important. That's what we're subtracting. Everything inside of them comes along. But just like up above, this is a much bigger deal here, because now I have to first distribute. Then I can combine like terms, meaning I'm not going to do anything with my x minus 3, but I'm going to distribute this negative. It's going to become minus 8x and plus 1, because I've just distributed this negative, and that's where we get really tricky and things start to go wrong when students are doing this. Keep the denominator and now combine like terms. X minus 8x, so x minus 8x is 7x. That's first term in the numerator, and I have a -3 plus 1 is -2, so it's 7x minus 2 over keeping the denominator 2x plus 1. We're done. Alright, so on the next page there are 6 problems to start. I want you to try those 6 problems. Press pause, try all 6 of those problems before you unpause and check answers. So to start, I haven't given answers yet, but notice 1, 2, 3, 4, they all have the same denominator. You keep it. Even in a problem like 4, when there's 3 different variables, but all 3 fractions, all 3 expressions have the exact same 3 variables with the exact same exponents. That's a common denominator. I keep it. Okay? Make sure you're on pause and finish all 6 of these before you check answers. Alright, so here's 1 and 2. Hopefully we got those 2. 3 and 4, definitely a little bit trickier, but if we got to this point, I'm really happy. And so should you be, because they are complete. Those are done. There's no like terms to combine in your numerators. 2y plus x squared, that's all we can do, that's all we can write. Same thing with number 4, j squared plus 3m plus 2n cubed. I'm not concerned about the order, it's all addition, so we're in good shape. Alright, last chance to try 5 and 6 on your own. If you haven't done it, please do so now. Okay, and here are our final 2 answers for those 6 problems. Double check, go back and look, make sure you got them right. Write down any questions you have if you did not. Moving on to the last 2 problems. These are a little bit challenging. If you want, go ahead and press pause. See if you can get them on your own first. Alright, so now, here we go. Common denominator. They both have factors of x minus 2 and x plus 3. They're the exact same denominator, so we keep them. I don't have to do anything. I don't have to multiply them. And in fact, not only do I not have to, I don't want to. Just like before, I want to keep those as binomials, and it's a subtraction problem. I am going to subtract those binomials. Bringing down the 5x minus 4, bringing down the 4x minus 7. Just like before, it's subtraction I need to distribute. So 5x minus 4 doesn't change. I get minus 4x, and I get plus 7 as my numerator. Denominator does not change. And I combine my like terms. Like terms here. 5x minus 4x. That's x. And then minus 4 and plus 7 is plus 3. I get x minus 2, x plus 3 in my denominator still. Do we notice anything that happens? Hopefully we do. Hopefully we recognize that this is a situation similar to the top here, when I had 1 over 9, which did not simplify, plus 5 over 9, which did not simplify, but when I added those, I got 6 over 9, and that simplified. That happens with our expressions as well. And when that happens, you do need to make sure you simplify them. I still have a factor of x plus 3 in the numerator and denominator. Those simplify. X plus 3 divided by x plus 3 is 1. Since x minus 2 is in the denominator, it stays in the denominator. I can put parentheses around that binomial if I want to, but I don't need to. There was nothing left in the numerator, so there really was that coefficient of 1 that we don't have to write. That is now completely simplified. Our last problem is something very similar. Again, if you haven't tried it and want to try it on your own, pause and try it. I'm going to work through it. Common denominator, yes, keep it. Numerators, it's addition, so I'm not as concerned about any of those details. I know I'm just going to combine like terms in an addition problem. I'll write it this way just to be consistent, but if I don't, that's not a problem. I don't have to worry about distributing anything. So here it's just combine my like terms. My 3x plus 2x is going to give me 5x. But what happens with my minus 8 and my plus 8? Well, negative 8 plus 8 is 0, so I don't have to add anything. It's a monomial in my numerator. Denominator stays the same, and once again, I have a factor of x in the numerator and denominator. Those simplify to 1. I am left with 5 over x minus 1. And I have completed the problem. Write down any questions you have. You do have a homework assignment tonight. Make sure you get any questions you have ready for me tomorrow.